Hi there. I was not expecting y'all to be here so soon. Anyway, hi, what's going on, guys? It's your boy, Ethboi Plays here today. I'm gonna be teaching you all how to do some complex mathematique word problems that revolve around using measurements of speed, distance, and time. Or in other words, we're gonna be doing some galaxy brain level stuff here. Now, to the recording studio! Okay, so I'm just gonna turn on this projector here. Boop! Alrighty then. Attention, everybody, class is now in session. Okay, now if you pay attention to the screen, let's take a look at today's word problem. My dear friend Lucas lives nearby a calm stretch of the Cowichan River. Today the current speed near Lucas's house is 1 kilometer per hour. Lucas puts his canoe in the water and paddles 5 kilometers downstream. And then he turns around and paddles 6 kilometers upstream to his grandfather's house, who lives on the river. The whole trip takes Lucas about 3 hours. What would Lucas's canoe speed be on still waters of the Cowichan Lake? Well, that is a mouthful. Okay, so the first thing we need to do when looking at this word problem is dissect the information from it. The first piece of info we're getting to look at is the distance Lucas had to travel in his canoe. And we look at the word problem and go, okay, we know that Lucas traveled 5 kilometers downstream. This is going to be represented with the variable d, subscript d. The reason we use subscripts is because we're dealing with multiple measurements. Because Lucas traveled both downstream and upstream, so that's why we're differentiating the distance, because it's different between the two. Next, we're going to look at Lucas's speed going down the stream. And this is going to be represented by the variable s subscript d, which is really equal to x plus the current speed, which in this case is 1 kilometer per hour. And the reason we're adding the current speed is because he's traveling downstream with the current. So you add the current speed to his base canoe paddling speed. Now the next variable we have to look at is time, or how long it takes to Lucas to paddle downstream, but we'll have to come back to that later, so just bookmark that in your head as it's very important. So next we're going to be applying the same logic we did to Lucas paddling downstream as we did to Lucas paddling upstream. So just like how we looked at the distance of Lucas canoeing downstream, the word problem also tells us how far he canoed upstream, which was 6 kilometers. This is represented by the letter D subscript U instead of D. The reason it's U is because he's paddling upstream instead of downstream. And just like with downstream, we can figure out the speed he traveled at by using the same method we did. Since he's paddling upstream, it's going to be x minus the current speed, which is 1 kilometer an hour. And the reason it's minus 1 is because he's having to paddle upstream against the current, making him go slower. Now remember how I said we had to bookmark that important piece of information? Well, this is where that's going to come into play now. Rather than the word problem stating and specifying how much time it took Lucas to paddle downstream and upstream, it instead gives us the total amount of time both trips took. So rather than having a set variable for time to give it a value, like it took him 30 minutes to paddle downstream and 40 minutes to paddle upstream, instead what the question gave us was the total of 3 hours. So it gave us the 2 times put together. It took him 3 hours to paddle downstream to like save on foods or whatever, and then paddle upstream to his grandpa's house. That took him 3 hours total. And this is really helpful because it helps us figure out what we're trying to solve. So in other words, what this all means is it sets up what kind of equation we're going to be using. Rather than time having a set value, it's the time upstream plus the time downstream equals 3, which helps us get a nice, neat equation. And what we can do with this equation is we get to start doing some very fun math. So instead of the equation just being time upstream plus time downstream equals 3, time has its own equation to solve for that we have to sub in. So time really equals distance over speed. So you're going to have your distance upstream over your speed upstream plus your distance downstream over your speed downstream equals 3. And since we already figured out what those values equaled at the start of this video, we get to now sub all those variables into our equation. So instead of having d subscript d over s subscript d, you should have 5 over x plus 1, and instead of having d subscript u over s subscript u, you should have 6 over x minus 1 equals 3. And from there we have some fractions to get rid of. And the reason we want to get rid of these fractions is because you can't add fractions with unlike denominators. It doesn't work, it's not fun, it's just bad. No, don't do that. Therefore, we have to find the lowest common multiple to cancel out our denominator so that we can actually add our equation. So that means that since our denominator on one side is x plus 1 and our other denominator is x minus 1, x plus 1, x minus 1, we have to multiply the entire equation by x plus 1, x minus 1 to cancel everything out. And so after you multiply, you should end up with 5 times x minus 1 plus 6 times x plus 1 equals 3 times x minus 1, x plus 1, and the x minus 1 and the x plus 1 are all in brackets because we have to close our doors, because closing doors is good. Were you born in a barn? I don't think so. And from there, it becomes a basic algebra problem, so you have to expand your brackets. So you're going to do 5 times x minus 1, which is going to equal 5x minus 5. And you're going to do 6 times x plus 1, which equals 6x plus 6. And that is going to equal 3 times x squared minus 1. Now the reason you just don't times 3 by x plus 1, or whatever you wrote first, is because you have to do x plus 1 times x minus 1 first. You have to follow FOIL, and you have to follow the rules of the lovely acronym BEDMAS, which says state you do brackets first. So you times your brackets first, and then you multiply and expand them. So so you multiply your brackets to get x squared minus 1, and then you can times that by 3. So now that you have your x squared minus 1, you can now multiply it by 3 to give you 3x squared minus 3. On the right hand side, everything still stays the same. You still have 5x minus 5 plus 6x plus 6 on the left. And so after all that, your equation should look like 5x minus 5 plus 6x plus 6 equals 3x squared minus 3. Now from there, on the left side, we have some like terms. And what like terms are, they're just terms that have like the same variable. So your x's and your x squareds, those are like terms. Like if you have 2x squared plus 2x squared, you can add those together because they're both an x squared. Or in this case, because you have 5x and 6x, and 5 and 6, you're able to put those two together. However, you can't add 6x plus 5, because those two aren't the same, right? So you're able to add 5x plus 6x and negative 5 plus 6, which gets you 11x plus 1 on the left side. And the right side still stays the same. It's still 3x squared minus 3. And now that we have our equation 11x plus 1 equals 3x squared minus 3, we have to set it to 0, because if you remember in the word problem, it's asking what would Lucas's canoe speed be in the still waters of the Cowichan Lake. So it's asking what is his base canoe speed. And in order to find that out, we have to solve for our variable of speed, which was x plus 1, x minus 1. So in order to solve that variable, we have to set the entire equation to 0. And since we're resetting the equation to 0 and putting it in general form just means putting the entire equation equal to 0, we have to keep the a term positive. And the a term is always going to be your x squared term, and that must be positive. Always, it can never be negative. So that allows us to figure out what side to move the equation to. So this means that since 3x squared is on the right-hand side, we need to take all of our terms on the left and move them over to the right side to set the equation to 0. So what you'll get is 3x squared minus 11x minus 4. I just did that math in my head because negative 3 plus 1 is negative 4. And you'll get all that equal to 0. And now from here, what we have is a lovely polynomial to factor. So in order to factor this thing, we're going to have to find a number that is equal to negative 12 and adds up to or has a difference of 11. Now you're probably thinking, where did we pull negative 12 from? And the reason we're using negative 12 is because there are no common factors that multiply out to negative 4 and add up to 11. It doesn't work, so we have to multiply 3 times negative 4 in order to see if this polynomial is factorable. So once you do all that, you should end up with 3x squared minus 12x plus x minus 4. And the reason you have 12x plus x instead of 12 plus 1 is because you have to bring the x variable down from 11. You're basically saying that 3x squared minus 11x minus 4 is equal to 3x squared minus 12x plus x minus 4, because negative 12x and x are common factors with our polynomial. So once you do all that, you should end up with 3x squared minus 12x plus x minus 4. And the reason you have 12x plus x instead of 12 plus 1 is because you have to bring the x variable down when you're factoring the polynomial. And since we have an entire polynomial that has 4 terms in it, we have to factor by grouping. So this means instead of trying to find a common factor between 3, 12, 1, and 4, x is equal to 1 by the way, we are going to have to split them into 2 separate terms that we can factor. So if you take 3x squared minus 12x and factor it, you'll notice that there's a common factor of 3x, so you pull that out. And that leaves you with 3x times x minus 4. And then if you look at the other term, positive x minus 4, well, there's no common factor we can pull out of x minus 4, so we just end up bringing x minus 4 down. And now since we have the common factor of x minus 4, we can reduce this polynomial to just 3x plus 1 in brackets multiplied by x minus 4 in brackets. And the reason we have 3x plus 1 is because when we were pulling down x minus 4, we also have to bring down the sign in front of the middle term. Okay, so now that our equation is looking really simple and not as scary and messy as we made it before, it's just time to solve for x. So what you're going to do is take 3x plus 1 and set it to 0, and you're going to take x minus 4 and make it equal to 0. And from there you can just do your basic algebra and solve the equation. So we're trying to isolate the variable x, which means that we're going to have to get rid of the second coefficient in the equation. For example, with 3x plus 1, we have to move the 1 to the right-hand side so that 3x equals 1. So that way we can divide by 3 to isolate x. And once you divide by 3, you find out that x equals 1/3, because 1 doesn't divide by 3, so it just becomes a fraction. And then you do the same for your other term, x minus 4. You set that equal to 0, then you move 4 to the right-hand side so that x has something to equal, and since it's on its own, there's no coefficient in front of x, there's nothing we can do, so x just ends up equaling 4. Now if you look at your answer here, you have x equals 1/3 or x equals 4. If you remember the beginning of the problem, originally our speed of the canoe was equal to x. So we have to look at our answer and get rid of one of our potential variables of what x equals. Because the canoe cannot have two separate speeds at the same time, that just doesn't make any logical sense. For example, if you're driving your car cannot simultaneously be going 60 kilometers an hour as well as 2. It just does not work that way. So we have to look at both of our x answers and look at which one would make the most logical sense. In this case, the answer to that is x equals 4 because x can't equal 1/3. 1/3 of a kilometer doesn't make sense as a speed. You can't go 1/3 of a kilometer per hour. Kilometers are in whole numbers only. Same with decimals. You don't go, I'm going 12.5 k an hour. Like it's just not right. When it comes to these word problems, like most of the time they're going to be asking you for whole number answers. So you're going to just choose the whole number answer, which in this case is 4. And if you don't think 4 is the right answer, what you can do just to double check it is sub 4 right back in and have 4. So sub in 4 in our original equation, which was 5 divided by x minus 1 plus 6 divided by x minus 1 equals 3. Instead of having x plus 1 and x minus 1, you're just going to sub 4 in for x. That was a lot of 4s in that statement. But yeah, that's how you do some big-brained, huge, big calculus maths. Thank you all so much for watching. I hope you enjoyed. I also hope this made some sense. Math is a very challenging topic to follow, so I hope this made sense. I hope I made it fun and enjoyable for you. I probably did a terrible job of explaining it, but I hope you followed along. I hope you all enjoyed. Thank you all so much for watching, and I will see you on the next one. Bye-bye! Howdy y'all, it's reflection time! So in terms of my approach to this project, it was really fun. I really enjoyed teaching this word problem and making film, because I love film. It's one of my great passions, so this was absolutely tons of fun. I love teaching and explaining things to people, and I'm genuinely considering being a teacher after high school, so this was just tons of fun. I love the experience, 10 out of 10. Would do again. It's great. And the reason I love doing this stuff like this is because it especially forces you to not only think critically just to solve the word problem in itself, but you have to think critically and figure out a way to explain the problem that would make sense for even people with zero math knowledge to understand and follow. And that is a very challenging thing for anyone to do. And something I kind of struggled with when writing the script, so I really hope it made sense, and I'm sorry if it didn't. I tried my best with visuals and everything, so I really hope it makes sense and it works. Yeah, it's a very hard thing to do, especially when I love to overcomplicate everything and ramble on for like 20 minutes, so lovely. But it was tons of fun and a very important life skill, so I'm glad I did it. I loved it. It was great. In terms of what are some of the biggest challenges with these types of questions, I feel students would really, or could really struggle with dissecting the problem. Because first off, that's a really important skill, and I feel students who struggle with that would be like, whoa, there are all these words and numbers, and they could get really intimidated and overwhelmed by it, so it's a very important skill in math to be able to just identify the basics of what the question is asking. So I feel like that could be somewhat of a challenge for students. Definitely one of the bigger challenges with these types of questions for sure. Another one is determining what types of equations you're going to use, because with these types of word problems, it's either your time variable has a set value, like the time to plow a field takes 20 minutes, or it's Reggie can plow the field in 20 minutes and his brother can plow it in an unspecified amount of time. Together they do it in 3 hours. Oh, you gotta find out Reggie's time or whatever. So there's different types of equations you get with the word problem, and I feel students could have a tough time figuring that out. I know that's something that took me a while to grasp anyway. Yeah, it's just learning to differentiate, and that could be haunting and tough for some students. And factoring is like, it's just a given that factoring is going to be tough for some students because there's so many rules you have to remember, so many different ways things turn out, and it's a lot to remember. So there's also a lot of places you can make mistakes with factoring if you're not careful. That can also be a very challenging aspect with these kinds of problems. It would definitely be one of the more It would definitely be one of the more common places students would make mistakes with these questions. That, and there are lots of places you could make, like, errors or sillies, as I like to call them, because there's, like, lots of places where you could just make a silly mistake with your, like, combining terms or cross multiplication. Like, there's just a lot of common problems with revolving around having to pay attention and to be careful, which is hard for some students. I would know, because that's something I struggled with. But yeah, definitely one of the more common problems or areas students would struggle with. Yeah, just stuff like multiplication and combining, like, terms and factoring for sure, definitely. And, like, yeah, thank you so much for watching. I hope you enjoyed. I'm sorry I rambled on for so long, camera. Jesus. Okay. Anyways, yeah, I thank you all so much for watching. I'm sorry I went on for so long. I know math can be a really hard subject to listen to, especially when I am talking for so long. So I hope the visuals made it interesting and palpable at least. I'm sorry if it wasn't. But thank you all so much for watching. I'm sorry this took so long to complete. My footage went corrupt 3 separate times and it was painful, but it's done now. Hooray! I did it. It's done. Thank you so much for watching. I hope you enjoyed. I really hope it made sense too. That's one of my biggest concerns, that it made sense and it was easy to follow along and it wasn't too overwhelming. But yeah, fingers crossed. Thank you so much. Bye-bye. Push the off button, Ethan.